This video is for Homework and Mastery 2.3, Section 9.1 in your textbook, the addition and multiplication principles of equality. What we're looking at here is looking at what we need to do in order to solve linear equations. We're looking at two principles, the addition and the multiplication principles of equality, to make the right side and the left side of the equation stay balanced, because we always have to keep the equation balanced in order to keep it equal. An equation uses an equal sign and indicates that two expressions are equal. In other words, 6 plus 7 equals 13. An equation always has an equal sign. 6 plus 7 equals x. The solution of an equation is the number which makes the equation true. 6 plus 7 equals 13. 13 is the solution for this equation since it makes 6 plus 7 equal x true. Equations that have exactly the same solution are called equivalent equations. 6 plus x equals 13, x equals 7 are equivalent equations because 7 is the solution to the equation 6 plus x equals 13. The process of finding all solutions of an equation is called solving the equation. In order to solve equations, what we're going to use are the addition and multiplicative principles to solve these equations. Now, some of the equations you may be able to just look at and say, well, this would make sense for it to be the solution. Others you're going to need to be able to solve. So I would like for you to get into the practice of solving each equation the exact same way instead of trying to do it in your head. When you start trying to do everything in your head, you're going to have major difficulties. So I want you writing down your process for all equations. The addition principle says if the same number is added to both sides of an equation, the results on both sides are equal in value. So it doesn't matter what I add to each side of the equation. As long as I add it to both sides, I'm still okay. Whatever I do to one side, I have to do to the other. But what I'm looking for is something that will cancel out the number that is attached to the x. So if I have a positive 6 plus x equal to 13, I want to get rid of the 6. So I want to add its opposite to both sides. Because whenever I add its opposite, a negative 6, the two 6's will cancel out. 6 plus a negative 6, those now go away. And then I have 13 plus a negative 6, which will result in x equaling 7. This is why I'm always looking to add the opposite of whatever is here to both sides of the equation. This way these will cancel each other out, leaving me only with the variable. But remember, whatever I do to one side, I must do to the other side. So let's try some examples. For example, I have a minus 6.2 is equal to a negative 3.5. So what I want to do is, when trying to solve this, I always have to keep my equation equal on both sides. I want to try to keep my equal sign lined up when I'm solving these. So I want to work down. I never want to work across my page because then I get lost in my process. So whenever I have a minus 6.2, I want to add the opposite of a negative 6.2. What's the opposite of negative 6.2? That's going to be a positive 6.2. So I want to add a positive 6.2 to both sides. Remember, whatever I do to one side, I must do to the other side. When I do this, these two will cancel each other out, leaving me with only an a on the left-hand side of my equation. Then I can take negative 3.5 plus 6.2 and solve that and get a is equal to 2.7. Now, in any of these equations, it's very important that you check your answer. You can check your answer by substituting the number that you find back in for your variable of the original equation, as I have done here. I put 2.7 in for A and said 2.7 minus 6.2. And yes, that does equal negative 3.5. So my solution checks out, and A equals 2.7 is my solution. Here's one where I actually have a variable on both sides of the equation. I have 3c minus 8 is equal to 2c minus 15. There's a couple of different ways I can start this equation to solve it. What I'm going to do first is I'm going to add the opposite of my negative 8 and get rid of it. When I do so, that's going to eliminate my 8 over here and leave me only with the 3c. When I add the 8 to the right hand side, that leaves me with negative 15 plus 8, which is negative 7. So I now have 3c is equal to 2c minus 7. I want to get all my c's I want to get all my c's to one side. So I'm going to add the opposite of this 2c to both sides, which means I'm going to add a negative 2c to both sides. This will cancel out the 2c's on the right hand side. 3c plus a negative 2c leaves me with c equal to negative 7. Again, plug this back into the original equation everywhere there's a c and check your answer. So I have 3 times a negative 7 minus 8. Does that equal 2 times negative 7 minus 15? Well, 3 times negative 7 is equal to negative 21 minus 8. 2 times negative 7 is equal to negative 14 minus 15. Negative 21 minus 8 is negative 29. Negative 14 minus 15 is negative 29. Negative 29 does equal negative 29. Therefore, c equals negative 7 is my solution. It did check out. Here's an example where I'm asked, is 5 the solution of the equation negative 10 plus 4 equals x minus 2? What this is asking me is, does 5 in place of x make this a true statement? So what I'm going to do is I'm going to substitute 5 in for x. And so I get negative 10 plus 4. Does that equal 5 minus 2? Well, negative 10 plus 4 is a negative 6. 5 minus 2 is 3. Negative 6 does not equal 3. Therefore, 5 is not the solution. So if 5 is not the solution, what will be my solution? Let's solve the original equation, negative 10 plus 4 equal x plus 2. X minus 2. Let's solve that for x. So what I'm going to do is first I'm going to simplify the right hand side, negative 10 plus 4, which gives me a negative 6. I have negative 6 equals negative 2. I want to isolate the x, get the x by itself. So what I'm going to do is I'm going to add the opposite of negative 2. What's the opposite of negative 2? A positive 2. So I'm going to add a positive 2 to both sides. When I do, positive 2 minus 6 will leave me with a negative 4. And the negative 2 and the positive 2 on the right hand side will cancel out. So I'm left with negative 4 is equal to x. Remember, I can always check my answer by substituting negative 4 in place of x and seeing if the left side equals the right side. In this case it does. You always want to check your solutions to see if you do have the correct answer. Let's look at one with a fraction. I know how we all love fractions. So let's look at this one. I have 2/5 plus y is equal to 1/2 minus 3/10. Well, I need to look at my fractions and first of all get a common denominator, because I can't do anything else until I get common denominators. So between 5, 2, and 10, what would my common denominator be? My LCD is going to be 10. So in order to get a 10 as my denominator, I need to multiply the 5 by 2 and the 2 by 5. Remember, what you do to the denominator, you must do to the numerator. So here is that shown. I have multiplied the 5 by 2, multiplied its numerator by 2. I've multiplied the 2 by 5 and multiplied its numerator by 5. When I simplify that, 2 times 2 gives me 4, so I have 4 tenths plus y equals 5 tenths minus 3 tenths. Now that I have a common denominator for everything, now I can subtract and simplify the right hand side of the equation. 5 tenths minus 3 tenths gives me 2 tenths. So I have 4 tenths plus y is equal to 2 tenths. I want to isolate y, or get y by itself, so I want to move the 4 tenths to the other side. How I do that is I'm going to add the opposite of a positive 4 tenths. What's the opposite of positive 4 tenths? That's a negative 4 tenths. So I'm going to add negative 4 tenths to both sides. When I do so, that's going to be 2 tenths minus 4 tenths, which will give me a negative 2 tenths. Remember to simplify negative 2 tenths. I can divide both the 2 and the 10 by a 2. 2 divided by 2 is 1. 10 divided by 2 is 5. So my final answer is y is equal to a negative 1/5. And remember, I can plug that back in to my original equation and check my solution. We've been working with the additive principle. Now let's look at the multiplication principle of equality. This says that if both sides of an equation are multiplied by the same non-zero number, the results of both sides are equal to the value. Meaning, again, if I multiply one side by a number, I must multiply the other side by the same number. Whatever I do to one side, I must do the exact same thing to the opposite side of the equation. For example, I want to solve this equation for w. I have 1/7 times w is equal to 3. We need to find the value of w. So how can I move the 1/7? Well, what I can do is multiply by its reciprocal. When I multiply by its reciprocal, that means I'm going to multiply both sides by a 7/1. Realize that when I multiply by 7/1, that cancels the 7 here and here. The ones cancel out, leaving me with just a w on the left-hand side. Equals 3 times 7/1. And remember that 7/1 is just 7. So I have w is equal to 21, which is my solution for my equation. Again, I can always plug it back in and check myself. The division principle says the exact same thing. If both sides of the equation are divided by the same number, the results will be the same. We must remember that we cannot divide by a number that is 0. It has to be any other number. For example, solve for z. If z is 21z is equal to negative 273. Well, I want to find out what z is equal to. I want to find out the value of z. So I have 21 times z. What is the opposite of multiplication? That will be division. So if I divide both sides by 21, 21 divided by 21 is 1, so those are canceling each other out. And then I have a negative 273 divided by 21, which will reduce down into z is equal to negative 13. So just make sure that whatever you do to one side of the equation, you're doing to the other. Also, make sure, like one of our examples, that if you have a variable on both sides of your equation, you're moving all of the variables to the same side of the equation. You have to get all your variables to the same side. You move the variables just like you do coefficients. If you add 2c to one side, you must add 2c to the other side. In order to move them, there's a toll that has to be paid, and it has to change their signs. If you have any questions, please let one of us know, and we'll be glad to help you.